Voltage multiplier. Transformers are very efficient devices for converting a high AC primary input voltage into a low secondary output voltage, or it can be used to convert a low AC primary input voltage into a high secondary output voltage. But what if we wanted to convert a DC voltage from one level to another? Then we cannot use transformers for this application. The voltage doubler is a type of electronic circuit that gives the output voltage which is equal to twice of the input voltage. This circuit is very useful when a higher voltage is needed out of a single lower voltage power supply. For example, many times, we need 10-volt power input in our projects, but if we have 5-volt power supply, then in this condition, we can use this circuit in our project to fulfill your requirements. This voltage doubler circuit allows the input voltage between 3 volts to 12 volts, and it generates output voltage approx 6 volts to 20 volts. In this project, we will see how to make a voltage doubler circuit using 555 timer IC. These are the components which are needed in this project. 555 timer IC, 8-pin IC base, 33 kilo ohm resistor, 1 kilo ohm resistor, 10 kilo ohm resistor, 10 microfarad, electrolytic capacitor, 100 nanofarad, ceramic capacitor, 1 red LED, 2 diodes, 1 N4007, 9-volt battery, PP3 battery connector, on-off, rocker switch, 10 PCB, 4 screw with nuts, and 4 plastic spacers. Before making the project, we will understand its circuit diagram. This is a 9-volt battery to power up the circuit. This is an on-off switch, which is used to start or stop the project. This is a power supply indication LED. This is a current limiting resistor to protect the LED from high current and voltage. 555 is a timer IC. It can work in 3 different modes: monostable, astable, and bistable mode. In this project, we are using it in astable mode, so it will continuously give the high and low signal at its output pin. These pulses will continuously charge and discharge the capacitor C1 and C2. This arrangement of capacitors is called charge pump. Diodes are used to stop the current flow in the reverse direction. When output of 555 timer IC is low, then diode D2 is in forward biased, and capacitor C2 get charged using the diode D2. Capacitor C2 get charged up to the supply voltage, which is now 9 volts. Now when the output at pin number 3 of 555 timer IC goes high, D2 get reversed biased and block the discharging of capacitor C2, and at the same time, D1 is forward biased and allow the C1 to charge. Now the 9 volts of capacitor C2 and 9 volts of input supply voltage will charge the capacitor C1 up to 18 volts, approximately twice the supply voltage. 18 volts is the theoretical value, but in practical, due to some voltage drop across diodes and other voltage losses, it will charge up to 15 volts. These components will be used to make the circuit. First of all, we will make a PCB base, and for that, we will take a 0 PCB and make a hole at each of its corner. Now, we will insert a 1-inch screw inside the hole. Now we will take a plastic spacer, and then we will use a nut to lock the spacer. Now our PCB base is ready. To switch on or off our project, we will use an on-off switch. We need to make a big hole to fit this switch on the PCB. Use a permanent marker to make the outline on the PCB. Use the tweezer to make the hole in the PCB. Use the cutter to cut the plastic. Now insert the switch inside the hole. Now we will solder the 1 kilo ohm current limiting resistor. This resistor will protect the LED from high voltage and current. Now we will solder the power indication LED on the PCB. Now we will solder the diode. Diode has two terminals, positive and negative. Gray line is showing the negative terminal, and other side is positive. Now we will solder the 10 microfarad electrolytic capacitor. Small pin of the capacitor is negative, and long pin is positive. Now we will solder 33 kilo ohm resistor. Connect pin number 8 of IC base with positive supply voltage. Short pin number 8 of IC base with pin number 4. Now we will solder the 10 kilo ohm resistor. Now we will solder the 100 nanofarad ceramic capacitor. This is an unpolarized capacitor, so we can mount it from either side. Now we will solder the PP3 battery connector. Connect the red wire with the positive terminal, and black wire with the negative terminal in the circuit. Now we will plug the 555 timer IC on the 8-pin IC base. Now we will solder the crocodile clips on the input and output of the PCB. These crocodile clips are used to connect the voltmeter with the circuit. Voltmeter is used to measure the voltage. Now give the power supply to the circuit and check its functioning. Our circuit is working perfectly. I hope you enjoyed the video and learned something from it. For any help or to clear your doubts regarding your project, you can contact us on our student care number 7007957715. To buy the items used in this project, you can visit our website www.erroltech.com. You can give us the orders on WhatsApp also. Thank you so much.